Good evening, everyone. So in the last class, we discussed about the resolution of a vector in 2 dimensions. But today in this class, we'll be talking about the resolution of a vector in 3 dimensions. So we'll be resolving a vector in 3 dimensions into 3 components. One component will be along X, another component will be along Y, and the third component will be along Z. So let's suppose that this is our Cartesian coordinate system. Let's suppose this is our Cartesian coordinate system, and this is our Y here, and this is X, this is Y axis, and this is X axis. And let's suppose this is the Z axis right here. This is the Z axis, right? And let's draw a vector. This is the vector A here. This is the vector A. And suppose that this vector A is making an angle of alpha with the X axis, an angle of beta with the Y axis, and it's making an angle of gamma in 3 dimensions with the Z axis. Let's suppose this angle is the gamma, right? This angle is the gamma here. So the component along x-axis will be nothing. It will be a cosine component, that's a cos alpha. And the component along y-axis will be nothing. It will be a cos beta. And the component along z-axis is going to be a cos gamma. A cos gamma. So these are the 3 components. These are the 3 components along x, y, and z. Along x, y, and z. So these are the 3 components along x, y, and z. So component along x is a cos alpha, and the component along y is a cos beta, and the component along z is a cos gamma. So we can write this vector in 3 dimensions as ax I cap. This is the component along x, and the component along y will be ay j cap, and the component along z will be az k cap. For ax is nothing, it's a cos alpha I cap plus a cos beta j cap plus a cos gamma k cap. So this is how we represent a vector in 3 dimensions in the form of rectangular, in the rectangular form. So these are the 3 components of a vector A. So if we try to find the magnitude of this vector A, the magnitude of this vector A is going to be mod of A. That's nothing, it's under root of A cos alpha whole square plus A cos beta whole square plus A cos gamma whole square. We'll be left with A square will be common. It will be cos square alpha plus cos square beta and cos square gamma and cos square gamma. The value of cos square alpha plus cos square beta plus cos square gamma, that's equal to 1. So from here we get modulus of A, that's nothing equal to, that's equal to vector A. That's the magnitude of vector A. So these cos alpha, cos beta, and the cos gamma, these are called as direction cosines. So cos alpha, cos beta, and cos gamma, These are called as direction cosines. These are called as direction cosines. We can represent a vector A like mod of A vector and multiplied with the unit vector along the direction of A. Along the direction of A. Let's suppose that the vector A is this is the vector A, and the magnitude of this vector A is represented by modulus of A. And let's suppose we have vector A that's equal to AI cap plus BJ cap plus CK cap, where A is the magnitude of the X component, B is the magnitude of Y component, C is the magnitude of K component for the Z component. So the cos alpha, that's the direction cosine, that's nothing, that's equal to AX upon mod of A vector, and the cos of gamma, cos of beta, that's nothing, that's equal to AY upon mod of A, and the cos of gamma, that will be given as AZ upon mod of A. So these are the direction cosines. The direction cosine is nothing, is calculated taking the magnitude of the X component upon the magnitude of the whole vector gives us the direction cosine along X. And similarly, we can calculate the direction cosine along Y and the direction cosine along Z. We know that our unit vector, it's nothing, it's equal to A vector upon mod of A vector. And the A vector is nothing, that's AXI cap plus AYJ cap plus AZ K cap upon the mod of A vector. So we can split it like AX upon mod of A I cap plus AY upon mod of A J cap plus AZ K cap upon mod of A. Now AX upon mod of A, it's nothing, it's cos of alpha. We can replace it with cos of alpha I cap. Similarly, cos of beta J cap plus cos of gamma K cap. So this gives us the unit vector of a vector in terms of the direction cosines of a vector. So this is the unit vector in terms of the direction cosines of a vector. So this is how we resolve a vector into three components in three-dimensional space, right? In the rectangular form. And if we have to find the magnitude of a vector A, suppose the vector A is given as xi cap plus yj cap plus zk cap. The mod of A vector is going to be nothing, it will be under root of x square plus y square plus z square. This is going to be the magnitude of this vector A. So let's try to solve this question. The question is, we have a vector A. The vector A is given as, that's I cap plus j cap plus root 2 k cap. We have to find AX, AY, AZ. We can clearly see that our AX is nothing, it's equal to 1, and AY is equal to 2, 1, and AZ is equal to root 2. The magnitude of X component is 1, magnitude of Y component is 1, and the magnitude of Z component is also equal to root 2. And the modulus of A vector is nothing, it will be given as under root of x square plus y square plus z square. That will be equal to under root of 1 square plus 1 square plus root 2 whole square. So it will be nothing Root whole square will be 2. 2 plus 2 is 4. So under root 4 is 2. So the magnitude of this vector is 2. And we have to find the direction cosines also. So the direction cosine is nothing cos of alpha. That will be equal to ax upon mod of a. And ax over ax is the magnitude of x component, that's 1. And the mod of a is 2. So cos of beta will be equal to 1 upon 2 once again. And the cos of gamma, that's going to be equal to root 2 upon 2. Or we can rewrite it as uh, root 1 by root 2. 1 over root 2. So these are the direction cosines. If we have to find the alpha, beta, and gamma, so alpha, beta, and gamma. So alpha will be nothing. It will be cos inverse of 1 by 2. That's equal to 60 degree. And beta is once again cos inverse of 1 by 2. That's once again equal to 60 degree. And gamma, that's cos inverse of 1 by root 2. 1 over root 2. So that's equal to 45 degree. That's equal to 45 degree. In the fourth part, we have been asked to angle of vector with x, y, and z. And we also calculated that angle with the x-axis is 60 degree, with y it's also 60, and with z it is 45 degree. So this is how we calculate the direction cosines of a vector if a given vector is in rectangular form. And we also try to find the direction of that vector with respect to x-axis, y-axis, and z-axis. And the direction is found by using the direction cosines, and we calculate the angle that the vector makes with x, y, and z. So let's try to solve this question. The question is that we have vector A and vector B given. The vector A is given as A, that's I cap plus 2j cap plus 2k cap, and the vector B is 3I cap plus j cap plus 10k cap. We have to find the resultant. So resultant will be nothing. It will be A plus B. So it will be I cap plus 2j cap plus 2k cap plus 3I cap plus j cap plus 10k cap. So 1 I cap 1 plus 3 will be, we have to just add the x component with the x component of one vector with the x component of another vector, and similarly y component of one vector with the y component of another vector. So I cap plus 3 I cap is going to be 4 I cap, and 2j cap plus 2j cap plus j cap is going to be 3j cap, and 2k cap plus 10k cap is 12k cap. So this is the vector r. That's the resultant of a plus b. And the magnitude of this vector r is going to be equal to under root of 4 square plus 3 square plus 12 square. So 12 square is 144. 144 plus 4 square 16 plus 9, that's 25. It's under root of 169. That's equal to 13. So 13 is the magnitude of this vector, and we have to also try to find the unit vector parallel to the resultant vector. The unit vector parallel to the resultant vector will be the unit vector of the resultant vector, right? So unit vector along the resultant of these two vectors, let's suppose that's r cap, it will be given as r vector upon the mod of r vector. And our r vector is, that's 4i cap plus 3j cap plus 12k cap upon the mod of r, that's 30. So this will be the unit vector along resultant vector. So this is the unit vector along the a plus b vector. And direction cosines of r vector. Direction cosines of r vector will be nothing. Let's suppose that cos of alpha is the We have to calculate cos of alpha, so it will be ax upon mod of a. Ax is nothing, that's 4 upon 30, or cos of beta, that's going to be 3 upon 30, and cos of gamma, that's going to be 12 upon 30. So these are the direction cosines of resultant vector r. So the question is that we have two vectors I cap minus j cap plus 2k cap, and b vector that's minus 2k minus 2j cap minus k cap. We have to find the unit vector parallel to r vector of a and b vector. So we have to find a unit vector which is along the direction of resultant of a vector and b vector. So a vector is given as that's I cap minus j cap plus twice k cap, and the b vector has been given as minus 2j cap minus k cap, right? So the resultant of these two vectors, it's r vector, that's a vector plus b vector, and our a vector is nothing, it's I cap minus j cap plus 2k cap, and our b vector is minus 2j cap minus k cap. So once again, we'll be adding the x component of one vector with the x component of another, and the y component of one vector with the y component of another. So I cap I cap, there's no x component of b vector, so it will be I cap here only. Minus j cap minus 2j k cap, it will be minus 3j k cap, and plus 2k cap minus k cap, it will be k cap only, right? So this is the resultant of the two vectors a and b vectors, and we have to find the unit vector, that r cap. That's the unit vector along the direction of resultant of a vector and b vector. So it will be nothing, it will be r vector upon the mod of r vector, right? R vector upon the mod of r vector. So r vector is our I cap minus 3j cap plus k cap, and the mod of r vector is going to be under root of 1 square plus 3 square plus 1 square. So it will be 9 plus 2, that's 11. So this will be the unit vector. So this is the unit vector along the direction of resultant of these two vectors, a vector and b vector. Now let's move on to the next topic. This very important topic. It has got numerous applications in the physics. So we'll be studying about the scalar product, or the dot product. It's also called as dot product. Scalar product or dot product of two vectors. With respect to vectors, we have two types of products we define as. One is scalar product or the dot product, another is we call as vector product, right? So these two products are in your syllabus, and we'll be discussing these two products separately. So what these products are, let's suppose this is our Cartesian coordinate system. This is our Cartesian coordinate system, and this is our y, this is our x, this is our y, and let's suppose there is a vector a, this is the vector a, and there is another vector b, like this. This is vector a and this is vector b, and the angle between these two vectors is given as theta. So these two vectors are inclined at an angle of theta, so the angle between these two vectors is equal to theta. So what we can do is that we can resolve this b vector into two components. We can resolve this b vector into two components. The component along this a vector will be the cosine component, that's b cos of theta, and the component perpendicular to this a vector will be nothing, it will be b sine of theta. So what we have done is that we have resolved a vector b into two components, one component along the direction of a vector and another component along the direction of p vector. So dot product is defined as, it's presented as a dot b. It's not a multiplication, normal algebraic multiplication, right? So a dot b. So it's defined as, first of all, it's called a scalar product because the output of this product is a scalar quantity, not a vector quantity. So we call it as scalar product. We get a scalar out of this, not the vector. So is the component of B vector along the direction of A vector. The component of B vector along the direction of A vector is B cos theta. So if we take the product of component or the projection of B vector along A, that's B cos theta, and do a multiplication of this component B cos theta with the vector A, that's mod of A, B cos of theta. So this is what we call as the dot product. So this is how mathematically we define the dot product of the two vectors. So what we do in dot product is we take component of A vector, component of B vector along the direction of A vector. So it's a product of component of B vector along the direction of A vector. That's what we call as A dot B. Or so A dot B can be defined as, that's A dot B vector. So it's mod of A vector, mod of B vector, and the cosine of the angle between these two vectors. That's cos of theta, right? Cos of theta. Or we can also define it like the component of B vector along the A vector, that's the A dot B. We can also write it like A vector we can write it as B vector dot eta cap, right? Where eta cap is a unit vector, along A vector. This eta cap is nothing. That's a unit vector along A. So the unit vector along A is going to be A vector upon mod of A. So that's how we define a dot product of the two vectors. Suppose that if theta is the angle between these two vectors, if theta is equal to 0 degree, right? Then A dot B is going to be equal to mod of A multiplied by the mod of B, cos of 0. Cos of 0 is 1, so we'll be left with mod A into mod B. So this is the maximum value of the dot product between the two vectors. So dot product is maximum when the two vectors are parallel to each other. It means that the whole of vector B is along the direction of vector A. The whole of vector B is along the direction of vector A, or there is no component of vector B which is perpendicular to the direction of vector A. So whole vector itself is along the direction of vector A. So mod of A into mod of B. If the two vectors are parallel to each other, so we'll be just doing the product of the magnitudes of the two vectors. Case second is, suppose the theta is equal to 90 degree. Angle between the two vectors is 90 degree. We know that cos 90 is nothing. It's going to be 0. So cos 90 is 0. If cos 90 is 0, so A dot B is going to be equal to 0. So the dot product of the two vectors, or the two vectors, are perpendicular to each other when the dot product of the two vectors is equal to 0. So whenever we have two vectors, this is vector A and this is vector B. This is vector A and this is vector B, and they are inclined at an angle of 90 degree. Their dot product is always going to be 0. Their dot product is always going to be 0. And let's suppose that the two vectors A and B are anti-parallel to each other. They are anti-parallel like this. This is A vector and this is our B vector. This is A vector and this is our B vector. This is A vector and this is our B vector. So angle between them is, that's equal to pi or 180 degree. And we know that cos of 180 is equal to, that's equal to -1. for A dot B. So A dot B. So A dot B is nothing. It's going to be minus AB. Minus AB, where A and B are the magnitudes of the vector A and B. So from here, we can see the range of the dot product. Range of the dot product. So the range of the dot product is A dot B vector can lie between, it can be greater or equal to minus A into B, less or equal to plus A into B. So this is the range of dot product. Range of A dot B. So this is the range of A dot B. So A dot B lies between minus AB and plus AB. And one more important property of dot product is that, suppose that A dot B, we define A dot B, then A dot B is also equal to B dot A. It means that dot product is commutative in nature. Dot product is commutative in nature. So A dot B will be equal to B dot A. So it doesn't matter whether you define A dot B or you define B dot A, they are both same. There's no difference between A dot B and B dot A. So they are commutative in nature. You will get the same scalar value when you do A dot B and the B dot A. So dot product is commutative in nature. Dot product is commutative in nature. And similarly, dot product is also distributive in nature. Suppose A dot B plus C vector. A dot B plus C vector. We can define it as A dot B. We can define it as A dot B vector plus A dot C vector. So this is what we call as distributive property of the dot product. Suppose if we do a dot product of a vector itself, A dot A vector. So this is nothing, it's going to be mod of A square. Mod of A square. Suppose we have three unit vectors, I cap, j cap, and k cap. These three unit vectors are the rectangular bases along x, y, z. These are along x, y, and z direction. I cap and j cap and k cap are the three unit vectors. They are mutually perpendicular also. They are mutually perpendicular also. So they are mutually perpendicular also. So it means that I cap dot j cap is going to be 0, or j cap dot k cap is also going to be 0, or k cap dot I cap is also going to be 0, because the mod of the magnitude of these unit vectors is equal to 1. So what we can do is that 1 into cos of theta, and the angle between these unit vectors is 90 degrees. So cos 90 is 0. So I cap dot j cap and j cap dot k cap dot I cap is going to be 0. And similarly, if we have I cap dot I cap, right? So it will be equal to 1, and j dot j, it's also going to be 1, and k dot k, it's also going to be equal to 1. So these are some of the properties of a dot product, and that's how we define a dot product. And there are some great applications of the dot product in physics itself. So these are the applications are the dot product is generally used, and there are many more applications. We use dot product to calculate the work done. Work done. We also use it to calculate the power. So these are some of the applications of dot product, right? That we use in physics also, and we'll be doing many more such applications as we go forward in the mechanics portion and in class 12 also. So let's try to solve some of the questions and try to apply the properties of this scalar product in some of the questions. And one more important point is that the dot product always gives us a scalar quantity, right? And the scalar product, it can be zero, it can be negative, it can be positive as well. So we have a question here. Find angle between A and B vector if A vector is 6 Newton and B vector is given as 4 Newton, and it has been given as A dot B that's equal to 12. So one of the important applications of the dot product is it's used to find angle between the two vectors. Angle between the two vectors. So dot product is used to find the angle between the two vectors. That's the important application of the dot product. One of the important applications. So in this case, in this question, we have been given a question that A vector has been given as, our A vector is given as 6 Newton, right? 6 Newton is the magnitude of this vector. But we do not know about the direction of this vector. So we'll be writing mod of A is 6 Newton and mod of B is equal to 4 Newton. And it has been given that A dot B is equal to 12. The dot product of the two vectors is given as 12. So we have to find the angle between these two vectors. For A dot B is nothing that's equal to AB cos of theta. So cos of theta will be equal to A dot B vector on mod of A mod of B. A dot B is given as 12 and mod of A is given as 6 and mod of B is given as 4. So 6, 2. So it will be left with 1 by 2. It means the angle between these two vectors is 60 degrees. So these two vectors are inclined at an angle of 60 degree. So that's how these two vectors will be inclined to each other. Suppose that this is a 6 Newton vector and this is a 4 Newton vector, right? The angle between these two vectors will be 60 degree. So this is the important application of dot product. It's used to calculate, to find the direction or the angle between the two vectors with respect to each other. Scalar product in component form. So let's suppose that we have a vector A. It's represented in component form or the rectangular form, that's axi cap plus ayj cap plus azk cap. And we have vector B here is defined as bx I cap plus by j cap plus bz k cap. So the dot product A dot B in the rectangular form is defined as, calculated as, we'll just multiply the x component of A vector with the x component of B vector and y component of A vector with the y component of B vector and the z component of A vector with the z component of B vector, and then add all these products. So it will be AX multiplied by BX and AY multiplied by BY plus AZ multiplied by BZ. So this is how we calculate the dot product if the two vectors are given in rectangular form or the component forms. So this is how we calculate the dot product between the two vectors if they are given in component form. And then if we have to calculate the angle between these two vectors, then what we'll be doing is that, suppose it will be cos of theta, that will be equal to ax bx plus ay by plus az Pz upon mod of A, that's under root of ax square so that will be equal to under root of ax square plus ay square plus az square, and it will be under root of px square plus py square plus pz square. So that's how we'll be calculating the angle between the two vectors if the two vectors are given in rectangular form. So let's try to solve this question. Find the work done if force F is equal to that's given as, and displacement is given also in the rectangular form. We have to find the work done. So work done is nothing, is defined as F dot S, that's the dot product of force and the displacement vector. So our force vector is given as 3i cap plus 2j cap plus k cap, and our displacement vector is defined as 2i cap 5j cap plus 3k cap. So what we'll be doing here is we'll just multiply the x component of force vector with the x component of the displacement vector and then sum all the products. So 3 into 2 will be, so this will be multiplied with this, 3 into 2 will be 6, and this will be multiplied with this, 2 into minus 5, that's going to be minus 10, and 1 into 3, that's going to be 3. So it will be minus 1 joule. So 9 minus 10 will be minus 1 joule. So the work done here is negative. You can see clearly the work done here is negative. So minus 1 joule will be the answer, correct answer for this question. So let's move on to the next question. If angle between A vector and B vector, if angle between A vector and B vector is 60 degree, we have been given that the theta between the two vectors A and B vector is given as 60 degree. Then find the value of A cap minus 2B cap minus 2A cap plus 4B cap, right? Where A cap, B cap are the unit vectors, right? These are the unit vectors, correct? So let's try to solve this question. So the question is we have to calculate A cap minus 2B cap dot with 2A cap plus 4B cap, right? So angle between A vector and B vector is given is 60 degree. It means that the angle between A cap and B cap is also going to be 60 degree because A cap is the unit vector along A and B cap is the unit vector along B. If the angle between A vector and B vector is 60 degree, it means the angle between A cap and B cap is also going to be 60 degree, and A cap and B cap are unit vectors, right? It means that the magnitude of these two vectors is going to be 1. So we'll be using a distributive property here. So we'll distribute these this dot product. So we'll be left with A cap dot 2A cap. So it will be 2A cap dot A cap, and A cap dot 4B cap. It will be 4 times A cap dot B cap, and minus 2B cap in dot 2A cap. It will be minus 4 B cap dot A cap, and minus 2B cap plus dot with 4B cap. It will be minus 8 B cap dot B cap. So A dot A cap, that's mod of A square. So these are the unit vectors. So the magnitude of A dot A is going to be 1. So it will be 1, 2 into 1 here, plus 4 times A cap dot B cap. It will be 4 times 1 into cos of theta. That's cos of 60 between these two, right? Similarly, minus 4, that will be 1 into cos of 60. And once again, minus 8, B cap dot B cap, it's going to be 1, right? So 2 into 1 will be 2, plus cos 60 is 1 by 2. So it will be 1 by 2 into 4, that is 4 upon 2, minus 4. It will be once again 1 by 2. So here, minus 8. So this 2 and 2 will get cancelled. This 2 and 2 will get cancelled. So we'll be left with, finally, 2 minus 8. That's equal to minus 6. So it means that the dot product of these two vectors is going to be equal to -6. So -6 is the correct answer for this question. So -6 will be the correct answer. So let's try to solve one more question here. The question is mod of a cap and a cap plus b cap is given as √3, and then we have to calculate the uh, a cap plus 2 b cap dot with 2 a cap plus b cap, right? So the dot product that we have to calculate is a cap 2 b cap, it's dot with 2 a cap plus b cap, right? And we have been given that a cap plus b cap mod of a cap plus b cap, it's given as √3. Now, if the modulus of a cap plus b cap is given as √3, so from here we can calculate the angle between these two unit vectors, right? So √3 is the resultant of a cap at b cap, so it will be a √3, that's equal to under root of a square, that's 1 square plus 1 square, because the mod of these are the unit vectors. So mod of a vector, mod of b vector is going to be equal to 1, right? So plus 2 into 1 into 1 of cos of theta, right? So from here we can write √3, that's equal to 2 plus 2 cos theta, right? Or we can just conclude that 2 plus 2 cos theta is equal to 3. 2 plus 2 cos theta, that's equal to 3. So our cos theta will be equal to 1 by 2, or theta is equal to 60 degree. Which means the angle between these two unit vectors is 60 degree. Now we'll be using the same angle to calculate the dot product. So once again, we'll be using the distributive property a cap dot to a cap. It will be twice a cap dot a cap and plus uh, a cap dot b cap, and then plus 4 b cap dot a cap, and then finally 2 b cap dot b cap, right? So a cap dot a cap will be 1, so it will be 2 into 1, right? And a dot b, it will be 1 into 1. The angle between them is 60 degrees, so it will be cos 60, and plus 4, 1 into 1, that's cos 60, right? Plus twice 1 into 1, right? So it will be 2 here. Cos 60 is equal to 1 upon 2. So it will be 1 upon 2 here. So 4 upon 2 here. And that's equal to 2. So we'll be left with 2 plus 2 will be 4 plus 5 upon 2. That will be equal to 4 into 2 will be 8 plus 5 upon 2. So it's going to be 13 upon 2. 13 upon 2. So the correct value of this dot product is going to be 13 upon 2. So 13 upon 2 is nothing, it's 6.5, right? 6.5. So option 3 will be the correct answer. So 6.5 is the correct answer for this question. So that's it for today, and we'll stop here, and in the next class, in the next coming class, we'll be discussing about the vector product or the cross product. Thank you very much.